Bismillahirrahmanirrahim, and hello everyone. I'm Abrar Hussain, PhD research scholar at International Center for Chemical Biological Sciences, University of Karachi, Pakistan. Today I'm presenting my abstract entitled The Antimicrobial Potential of Probiotic Strain and its Importance, especially in biotechnological processes. So, very brief about the probiotics. The concept was developed by Russian Nobel laureate scientist Lee Metcalfe in 1907 and proposed that if we can change the gut microbiota with beneficial microorganisms, they can change the lifespan of the host microorganism. But the term probiotic was properly coined in 1965 by Lilly and Stilwell and proposed that these are the substances which are secreted by microorganisms and used to alter the host microbiota, have the potential to modulate immunity and can enhance the intestinal function. But the proper definition and proper guideline was proposed by the International Scientific Association for Probiotics and Prebiotics in 2013 and defined probiotics microorganism that these are live microorganisms that, when administered in adequate amounts, confer health benefits on the host. So once the concept was introduced into the world, the researchers around the globe are devoted to explore the multiple dimensions of the probiotics field. But currently, 7 genera are proposed for their probiotics potential, and broadly, microorganisms are divided into 3 types: the self-strain, which are have known probiotics, available probiotics in the market; the doubtful strain, which have some doubtful in their strain whether it can be used as probiotics or not. And the pretty known example of this category is the genus Enterococci. And the risky strain, which have prone risky substances, are the virulent substances which are not used as probiotics. So how a microorganism are selected for their probiotics potential? So various guidelines were proposed by the EFSA and other guideline. And one of the top guideline, one of the type selection criteria for a microorganism to be used as probiotics is their antimicrobial potential. Now, the antimicrobial potential is the ability of one bacterial species or strain to kill other pathogen and mostly in their close vicinity. How they can kill this microorganism? They can mostly kill by the depletion of the nutrients availability, and they can also by secretion of antimicrobial substances. So what was the object of this study? This is just kind of a review study which can enhance and which can aim to explore and give a recent insight into antimicrobial potential of probiotic strain. What are antimicrobial potential of any probiotic strain? What is its importance, and how we can determine the antimicrobial potential of a probiotic strain? And it can also highlight the important biotechnological applications which are obtained through the antimicrobial action of probiotics. For example, they are used to enhance the shelf life. They can also use to store and store the food substances because they have the ability by this antimicrobial potential to kill the foodborne pathogens. How the study was conducted? The material was selected by from literature were collected from different searching different terms in various websites. For example, the probiotics health benefits. For example, the probiotics selection criteria, the guideline for probiotics, etc. And the gray literature were omitted. They were not included in the study. They were analyzed, critically analyzed, downloaded, and then the literature survey was evaluated. Keep in mind the selection criteria, especially the antimicrobial potential of the probiotic strain. So what we know about the probiotics, which was already pretty known in the literature, that antimicrobial potential is the crucial properties for any probiotic strain which must be present in the strain which someone claimed that this strain may be used as probiotics, or especially in feed additives. The gut pathogens, which are mostly known as enteric pathogen, and some of them are causing harmful to the host gut. And the available data also show that probiotics have the ability to eradicate and kill these pathogens by different ways. Although the exit mechanism is not known, but it is recommended that they can perform this action by the secretion of antimicrobial peptides, for example, bacteriocin, by the production of short chain fatty acid, nitrous oxide, hydrogen peroxide, and they can also increase the secretion of IgA, which are considered the substances or the stimulus to increase the killing pathogens, killing potential of probiotic strain, and can kill the enteric pathogens. So these are just proposed methods which are followed or which are recommended that a probiotic strain can kill pathogen, eradicate pathogen from the host, especially from the host gut conditions, and can perform their probiotics potential. So now the available method in the literature which are recommended for the evaluation of antimicrobial potential of probiotic strain include the plate assays. For example, we can perform this by different phenotypic assays by blood tests. We can also measure or identify the antimicrobial potential by calculating their optical density by using spectrophotometer. While genotypically, which is very important according to the literature, it is recommended that the probiotic strain must be genotypically validated. Yes, that the negative aspect like virus vector and antibiotic resistance gene etc. is not present, and they can have the potential to produce antimicrobial substances. So they must be assessed and must be screened by using multiplex or single PCR conditions. So very simply, we can conclude that probiotics have versatile health benefits, and currently they are very extensively used in different industries, for example, food industry, pharmaceutical industries, and various biotechnological properties. This extensive usage of probiotics in different industries, mostly because of their antimicrobial actions, which may be achieved by the change in the gut physiology and by the secretion of substances. Now, if we can understand and know the antimicrobial potential of the probiotics microorganisms, so what we get? So definitely we can knowing about the exit mechanism can help us, the researcher, to identify the ways in which we can use probiotics for more and more multiple purposes, and they can enhance the, especially their biotechnological processes. We can also manipulate their genetic material, or we can also play with their genome also. So by knowing the exact mechanism how a probiotic strain can kill or eradicate a the pathogenic microorganism, can help to increase their biotechnological association. Thank you very much for your kind attention.